Kindervag 10 years ago was considered to be a complete idiot. At least that's what he told me last year by some people. His ideas have caught on enormously. When the Google CIO calls you, your concepts and ideas, the thing to do in security, you know you're onto something good. So it's with great pride that I introduce John Kindervag to talk about Zero Trust today.
Thank you, thank you. Thank you, Jan. So today I'm going to talk to you about the 3 innovations that are fueling the adoption of Zero Trust and why technology is making my life so easy. But before I do, I have to ask an important question because it's been bugging me all morning. Why is there a single pink chair here? Does anybody know? Are we waiting for a princess or something here? This just is so out of place. Does anybody else, does that not bother you? You didn't notice, did you? You're such a guy, right? There's a lone pink chair here in the middle of it. It certainly must signify something. What's it about, Jan? Is there a princess?
I will tell you when you finish.
You'll tell me when I finish, okay. I just wanted to get that off my chest because it's been driving me completely nuts. You know, everything is all white and very European here, and then we have a pink chair. And it just feels like something bad is going to happen because of that pink chair. So I don't know about that, but we'll find out. Hey, innovations that are fueling Zero Trust. I'm going to talk to you about that today, and I'm going to put it into some context. First, I'm going to talk to you about the data, and really, in our world, it's all about the data. Then I'll give a quick introduction to Zero Trust if you're not familiar with it. Then I'll talk about these technologies that are igniting it and kind of do a little summary, maybe a couple of questions if we have time. So the thing we need to know is it is all about the data. The data is what's causing the problems. You see, we live in a world that's very cloudy. It's not so bright, really, the world in terms of IT and security. It's cloudy, not bright, but I appreciate the optimism of the Dutch by naming this conference Bright and Cloudy. But you have software-defined networks, BYOD, all these things happening. They're changing the world. People don't know what to do with all this stuff. And they've got data moving all over the place and proliferating. So the thing that has caught everybody's attention is Target. I'm not the first person to mention Target, but I do want you to understand that we do live in a post-Target world. Target has changed the game, not because of the way the breach happened. That's not really very relevant, but what happened as a result of the breach? The CEO was fired. That's what happened. That's a big deal. I was here in Amsterdam, I guess just a couple of months ago, and I was at a place down by Nijmegen, and we were with the VP of IT at a large corporation, and he had 3 images taped above his phone so he could look at them every day. The first image was this logo. The second image was the image of the CIO from Target who got fired. And then the third image was a photo of the CEO of Target who got fired. Because that's now his job, to keep everybody from getting fired. So prior to December 13th, 2013, that was the pre-Target world. That was BT, before Target. We are now living in year 1 AT after Target. This is year 1 AT after Target. Target has changed everything, and we live in a post-Target world. And if that wasn't bad enough, in the US we had Home Depot. You guys seen the Home Depot attack? Millions and millions of credit cards. I got the notice last week. I get a year's free credit monitoring. Yay! Come on, somebody get excited for me, because I got breached, right? It's bad when this happens. Data is the new oil, and a data spill or a data breach is really the worst thing that can happen to your brand. Well, why is it happening? It's happening because 20th century networking is a mess. When we talk about that 3-tiered architecture that is so commonplace, somebody said to me, well, we're very secure because we have a 3-tiered Cisco architecture. Oh, good. That in, $18 will get you a cup of coffee. It has no meaning or value to security. In fact, it is the problem, not the solution. Look at that thing. Look at that image. It is a complete and utter mess. And when it falls down, we build it up the same way, so we better do something different. Because if we don't, we're going to keep getting breached. We're going to keep getting destroyed. So what should we do, right? The first thing is it's all about the data. Data is like oil. It is the new oil. I come from Texas. We love oil down in Texas. We love to pump oil. We love to sell oil. We love the things that oil buys us. We don't like it when oil spills all over the Gulf of Mexico. Same thing is true about data, because, you see, we're in a data economy. We've shifted from an information economy to a data economy where raw data has value, just like raw oil has value. You have a barrel of oil. We call that crude oil. You can go on the commodities market and you can find out what West Texas crude is selling for today per barrel. Raw data, like credit card information, has value on open markets. Hackers buy and sell it. But as you refine oil, it gets more valuable. You turn it from West Texas crude into gasoline, jet fuel, diesel fuel, kerosene. You turn it into plastics. All those things have more and more value. Same is true with data. You start with raw data, a single credit card number, something else, maybe a name. You start doing some business analytics, marketing analytics. You can sell that to somebody. You can use it to drive somebody's buying habits. How many people shop on Amazon.com? Anybody here? Yeah? Yes, you do. Of course you do. Because it's a great frictionless buying experience. And what makes it happen? Data. That data says, hey, people who are looking at the same thing as you are looking at right now bought this. Or based upon what you've bought in the past, you might be interested in that. I bought a lot of things because, yeah, I am interested in that. There's 1 trillion products out there, and they're telling me the ones that I might be interested in so that I don't have to know what to look for. That's very valuable data. Now, if data is the new oil, that can sound scary because data seems like this massive project that you just understanding data. How do we deal with data, right? We've got big data. That's the garage that IT built for the business. Business could throw its crap in it. That's all big data is. So we want to talk about big data. We want to monetize big data, but we don't understand data itself. And I'm here to tell you that from a security perspective, there's only 2 types of data in the entire world, only 2, right? Simplify it so that you can wrap your mind around it. What are the 2 types of data? Well, there's data that someone wants to steal. That's the first type of data. And then there's everything else. So in this equation, what do we want to protect? We protect the stuff that people want to steal. I used to use the analogy about, pictures of your kids, photos. No one wants to steal photos. I found that's not true anymore. If you're a naked celebrity, people do want to steal your photos. But again, it's valuable because people want to steal it. Social security numbers, naked celebrities, they're all the same. The zeros and ones are just in different orders on the storage medium. So what do people want to steal? Well, typically outside of naked celebrity photos, there are 4 Ps. I don't even know how to add this to my equation here because that's such an outlier. But for businesses, there are 4 things you need to remember that people want to steal. 4 Ps, we call them. The first one is PCI, or credit card data. PCI is the world's largest vertical market. It's the only compliance initiative that's the same for everybody in the entire world, no matter how big or how small you are. It's the lingua franca of security. I am a recovering QSA, formerly doing PCI work. I can talk to anybody in the world about PCI, and we know exactly what we're talking about. The second is protected health information, PHI. That got mentioned a little bit earlier today when we talked about the breach of health records. Very, very important. That's the second P. The third P is PII, personally identifiable information. Every human being on the planet has some sort of digital signature that's part of their PII, some sort of record that makes that particular piece of data very sensitive. And then finally, and often overlooked, is IP, intellectual property, the stuff that gives you a competitive advantage. Why do APT attacks exist? Not because it's a cool kind of malware to make, but because the objective is to steal intellectual property, and so I need some pretty sophisticated tools to do that. Why do I steal intellectual property? Because it's a whole lot easier to steal somebody's drawing of a wheel than to invent my own wheel. It makes perfect economic sense. It's very, very economically effective to steal other people's ideas. And so that's why APTs exist, not because, boy, that's a fun piece of hacking that we can do. So we've got a little equation that we share with our clients at Forrester called, that's this, 3P, the PCI, PII plus IP, intellectual property, equals toxic data. Toxic data is the data that gets you in trouble if it gets outside of your organization, either with regulatory or legal entities. So what do you protect? You protect the toxic data. Don't protect the stuff that nobody wants to steal. I see a lot of people trying to protect things that no one wants to steal because it feels important to them. But it's not important to a threat actor. So we've evolved this into a big framework that our customers use to protect themselves. We call it the Data Security and Control Framework. It contains 3 Ds. Define your data. This is data discovery and classification. Folks, until you know where your data is and how toxic it is, ultimately you won't be able to protect it. So you need to be thinking about defining your data, knowing your data, understanding your data. Think about having identity attributes for your data. The next thing we need to do is dissect our data. We need to look at it as it moves across our network. Too often these breaches happen because the breached data is invisible to people. We didn't know we were being hacked. That happens all the time. So you need to do data analytics and intelligence and monitor what's going on. And then you need to defend your data. And it doesn't matter how many technologies you buy, how many products you put in, how deeply you embrace the concept of expense in depth. That idea that you need to spend a lot of different money everywhere in order to have more and more security. So you can only do 4 things. You can control access to a piece of data. You can inspect that data as it's being accessed. You can dispose of your data, or you can kill your data. You can abstract it through tokenization, masking, or encryption. That's it. That's all you can do. But it's that I want to talk to you about today, because we enforce the defending of data through the concepts of zero trust. So I'm going to introduce you to zero trust. How many people are familiar with some of the concepts? Either were here last year or been around, yes. You know, and the Netherlands is the epicenter of zero trust. Leon tells me that people adopt it because it makes sense, because you can look at a zero trust network and say, we do the exact same thing with the dikes, right? The dike system. So it makes there's a physical analogy that we don't have in other parts of the country. Like I couldn't have that same thing happen in New Orleans, Louisiana, where they never figured out how to actually build a dike, even though they were under sea level the whole time. They just, you know, this is the difference between the Netherlands and New Orleans. The Netherlands has sort of a zero trust view of water, and New Orleans took the same risk mitigation attitude that most enterprises do, and that's called hope. Gee, I hope that doesn't happen. Hope that hurricane never hits. That's what most companies do. Instead of having, you know, some real risk methodology, they actually have the hope methodology. So let's look real quickly at what zero trust is. Zero trust came about because we identified this idea of trust but verify as the fundamental problem that exists. Every breach is a trust breach. Every breach of any network is a trust breach. The idea that we think there needs to be trust in networks is the problem. Why is that? Because when you trust someone, you don't verify them because it would be rude. Or you're so cheap that you're not going to spend the money on verification because you already trust them. So all breaches exploit the trust model, whether it's a Bradley Manning, whether it's an Edward Snowden, whether it's a Target, or whether it's a Home Depot. There is a moment in time when an attacker either has internal access and is therefore considered trusted, or a packet, an electron or a photon moves a micrometer across a wire and becomes part of the internal network, and suddenly their trust privileges are elevated. That's what happens. That's how breaches occur. They exploit a broken trust model. Well, you know what? We don't need trust to move a packet from point A to point B. There is no trust flag in TCP. It is completely meaningless in the digital world, and yet we seem to want to do it. Why is that? Because we anthropomorphize the network. And people will complain to me, you're saying that our users aren't trustworthy. That's a bad thing. You know, we don't want to give that message off, and I'm not saying that at all. When you want to talk about trustworthiness of people, ask Julius Caesar. Don't come to me. That's a philosophical question that I can't deal with. But I can say something much more profound, and that is that people are not packets, and only packets run across networks. So we just don't trust any packets. People, they're fine. Trust them, don't trust them. Doesn't matter to the network. So we have to get rid of this idea of trust but verify, and that's where zero trust comes in. You see, if you're like me and you've installed a lot of firewalls, you put the evil internet on the old untrusted side of the network, right? And then the internal network was on the trusted side. But that didn't help protect against Bradley Manning or Edward Snowden, did it? In fact, it doesn't help to protect against any breach. Every good attacker knows how to become a trusted user and elevate their privilege. And they elevate their privilege just by moving their packet from one part of the network to another. They don't have to do anything. That's what's so fun about it. When I was a penetration tester, it was just so fun. You would get access to the internal network by one way or another, and then suddenly you had access to everything because no one's looking for you there. And then when the breach happens, we're always looking at the perimeter. Right? We're looking for all of those alerts. And it's a little bit like a drunk who spends his time looking for his lost keys under the street lamp. Not because he lost his keys there, but because that's the only place where there's any illumination. Where'd you lose your keys? Well, let me help you look for them. Well, I lost them way over there, but there's no light. So I'll just crawl around on my hands and knees right here because I can see. That makes no sense. But drunks do it all the time. We in the enterprise IT, we function like drunks. We are a bunch of drunkards running around looking in the wrong places. So we need to adopt this model of untrusted and untrusted, or zero trust, so that we illuminate the entire network, not just one little piece of it. It's all about visibility. So there's some basic concepts of zero trust that I want to share with you. The first one is all resources are accessed in a secure manner regardless of location. Doesn't matter whether you're coming from an iPad, an iPhone, an Android phone, whether you're internal to the network or whether you're external to the network, whether you're coming from one country or another, it's all the same. It's all going across Ethernet. It's all a packet. I was so frustrated last night. I went to go to Netflix to watch a movie, and it said, Netflix has not come to this part of the world yet. What do you mean it hasn't come to this part of the world? This part of the world is a routing statement. Let's get real. What is it that makes the world flat? Ethernet and the ability to route packets. So all of us live in the same neighborhood. There is no this part of the world or that part of the world. We all live in the same bad neighborhood. It's called the internet. Next, we need to do access control on a need-to-know basis, and we must enforce it. As an auditor, I know there's a lot of access rule policies, but they stay in books. Why was Bradley Manning successful? Why was Edward Snowden successful? Because they had access to everything. And I venture, if I went in and did a little pen test on your network, if I got access to your internal network through maybe your VoIP network, through your wireless network, through your MPLS network, once I got access to your internal network, I'll have access to every single resource. Because the only access control you're probably doing is throwing a few GPOs in Active Directory. It's not going to keep me out. You're not doing real access control. So we need to change our model from trust but verify to verify and never trust. Verify, verify, verify. This is about getting visibility. How do we do that? We inspect and log all the traffic on our network, not just the stuff on our perimeter. If you're just looking at the perimeter, you're only looking at maybe a half or a third of your traffic. We talk a lot about north, south, east, west. What about northwest to east, southeast traffic? What about southeast to northwest traffic? What about all the ways that traffic flows? You better be watching all of it. And don't tell me it's hard. That's just an excuse. The real excuse is that you don't want to know. There is value in blindness. Value in blindness. The CIO of one of the world's largest companies who has the credit cards of everybody in this room once said to me, I don't know what's happening on my internal network, and I don't want to know, because if I knew, I'd have to fix it. That translates into effort, and most importantly, that translates into money. Euros, dollars, yen, it doesn't matter. What do businesses not want to do? They don't want to spend money, because it doesn't seem like their business. When the Home Depot security folks went out and asked for more security budget, they were told no, because all we do is sell hammers and nails. No, you don't. That's not even your business. You just think your business is hammers and nails. Your business is the compliance that you have to deal with. Your business is you're a credit card merchant. That's your real business. Your business is you have bandwidth. You have something that people want to steal. That's your real business. So inspect and log all the traffic, not just the stuff on the outside, folks. If you're only doing a SIM looking at syslog, you lost. Just give it up. Go home. Start a new career. Doesn't matter. And then let's design our network from the inside out, not from the outside in. I used to be a network engineer. I'm a recovering CCNA as well. And we would install these networks. You know, we'd put the main router in, and we do all the OSPF, or if we were really good Cisco guys, we'd do the EIGRP and IGRP, so it wouldn't be interoperable with anything. And that was the way that you did it if you were a good customer, right? Is this touching a nerve for you there, my friend? And then you'd install the firewall and the core switch, and then you'd spend an inordinate amount of time on spanning tree. Boy, we loved our spanning tree, didn't we? Boy, get that all, well, I got some elegant spanning tree going. And ask the CEO of any country, of any company, what spanning tree is. Just ask. The business doesn't care about this, but the business cares about the data, and yet we built these great, elegant networks, and we had no idea where people plugged the data into. No idea. We were completely clueless about it. So we need to start at the data. That's what has to be protected. You see, the network, the devices, the users, they're immaterial. We're not about protecting them anymore. We're about protecting the data, because we can't control the network. Part of it's going to the cloud. We can't control the devices. We got BYOD. What's the one thing we might be able to control? The data. So zero trust is data-centric. Start at the data. Build your network out from that. This is an example of zero trust. This is the man in the center. That's Barack Obama. He's the President of the United States. Does everybody recognize him? Just curious. It's hard to recognize him because he's not playing golf, so it's kind of a little bit out of context. But I chose this image because it explains zero trust. I don't know if any of you have ever been around one of these security details. I was once around one doing some work for Vice President Gore. And the security details are very intense, and they search everything, and they have dogs, and they give you a special little lapel pin that you wear that only has been issued for that day. They're very intense, and to me, they epitomize what zero trust is. Because in a way, what we do now is if we were a security detail and we walk around and go, hi, are you the President of the United States? I'm looking for him. I'm supposed to protect him, but I don't know who he is, don't know where he is. Secret Service, they know who the president is, they know where he is at all times, and they know that you're not him. So I was there at an event doing some work, one of the behind-the-scenes guys, and I said to my Secret Service agent who was standing by, I said, hey, I need to use the restroom. And he said, okay, let's go. Let's go. Yeah. Go to the bathroom sometime with a man who's carrying a submachine gun. You want to talk about shy bladder syndrome? Whoa, you know, just guy's got an Uzi in a bag. So that's what Zero Trust is. It is the new model of information security that identifies the fundamental problem as a broken trust model. That's what's broken, where users and traffic inside the network are trusted and those external to the network are untrusted. There's nobody trusted here around the president. You go up anywhere near him and you make a sudden move, right? One friend of mine was in the news business and he was around one of the presidents, and next thing he knew, he was flat on his back, or flat on his stomach, and he heard a voice in his ear, and he says, "It's best not to make sudden moves around the President of the United States." And then he felt a bunch of hands frisking him, and then suddenly there was nobody around him. And he was like these people magically came in, took him down, frisked him, and then let go of him and let him go on his way. That's what Zero Trust is. That's what we want to do to every packet. Frisk every packet. So there are 3 technologies that are igniting Zero Trust and are going to make it ubiquitous. So those are the development of next-generation firewall technology that serves as a segmentation gateway, the development and adoption of network virtualization, and agile programmability powered by centralized management. Those are the 3 things that are happening. And that's what means that I'm always on a plane, because of those 3 things. So let's look at the first one, the development of next-generation firewall technology to function as a segmentation gateway. Because Zero Trust starts at a segmentation gateway. A segmentation gateway is taking all of the various things that we've done in security, all these little conga line of security controls, firewalls and IPSs and access control and content filtering and activity monitoring and encryption, and we put it all together in a single box that has firewall and IPS and access control and content filtering and activity monitoring and crypto, and then it has the ability to forward packets and move them around a network. And this is what we call a segmentation gateway. And when I came out with this idea in 2008 or so, it was kind of a pie-in-the-sky thing. It was aspirational. And then vendors came out and they built these things called next-generation firewalls. And I'm especially gratified to be sharing the stage with Chris King, who you saw just before me. Chris and I have been friends for many, many years, because when Chris first was working for Palo Alto Networks, he came across Zero Trust, and it resonated with him, and he called me up and he said, "You know, I think our box is a segmentation gateway. Let's talk." And so we've been working together since 2008 or 2009 to articulate this message and explain this vision, because now that we have next-generation firewalls, which are very, very high-speed boxes that move packets and do deep security and have a lot of different interfaces and can meet the demands of the modern network, we can build the security into the DNA of our network. And we can start breaking down those walls between networking and security. And so this drives the future of network design. We can have these ideas of microsegmentation, or what we call MCAPs, microcore and perimeters, where we have similar functionality and global policy attributes enforced at the segmentation gateway. And then we can manage this by a centralized switching fabric. And it is my firm belief that management is the new backplane. If you're worried about your switch backplane and how you're going to manage it, don't worry about that, because the management part is going to create a new backplane. The physical backplane is irrelevant. The logical or software-defined backplane, that's what's important. So we can do a lot of things much easier. We can create a data acquisition network where we can inspect and log all traffic in a Zero Trust network. So when you say to me it's hard to inspect and log the internal network, not in a Zero Trust network, it's not. And then we can make a highly scalable and segmented network using Zero Trust. Microsegmentation is very important. Why did Target get breached? Ultimately, it was because it was flat. It was a flat network. Flat networks are easy to breach. Flat networks are easy to own. Not by you, but by the attackers. There are a lot of attackers who own networks. The enterprise pays the bill, but they own the network. And then all of these things are designed to support mobility. We don't need individual NAC agents and a lot of crazy costly stuff if we have zero trust, because now we're going to inspect how people are accessing the data. Remember, it's data-centric. So I don't care what device you're coming from. I care what data you're going to. And then ultimately, we can build zero trust on top of your existing network and augment what you're doing. So it's not a rip and replace. And this is why it's adoptable, because it's actually less expensive than adding a lot of other things that you might do to become more secure. The second big driver that we're seeing is the development and adoption of network virtualization. And Chris was talking about that just a moment ago. When he went from Palo Alto Networks to VMware not too long ago, he called me up and he said, "Dude," I don't know if he said dude really, but I'll pretend, he's from California, so in my mind, he said dude. He said, "Dude," did you say dude? Probably you said it, dude. "Dude, we build zero trust networks by default." That's what network virtualization does. That is the excitement, right? Because, see, zero trust was always designed to be network agnostic. We knew there had to be changes to the network. The old 20th century hierarchical network had to go. It just has to go. It's the problem. It has to go. It's going to go one way or another. And if you don't believe that it shouldn't go away, then eventually there's another career path out there for you somewhere, I'm certain. So zero trust, it's so much easier to do when we have these new meshed, fabric, whatever you want to call software-defined networks, virtualized networks. It doesn't matter. It's agnostic to whatever networking future is out there, because we just put the segmentation gateway, whether physical or virtual, in there. And we can now support this more easily. And what's especially important as network fabrics grow, there is a bifurcation of all the pieces of your network. We've heard about public cloud and private cloud and hybrid cloud. But what's even more amazing about all that stuff, it isn't just we're going to put some parts of the network or some parts of the workload into one of these three clouds. No, we're going to put one little part of an application into one or different parts of the cloud. So a single application might exist across a public cloud, a private cloud, and a hybrid cloud all at the same time. And then at runtime, when the user accesses that, they now have to pull that all together. And so that kind of network agility is so important moving forward. So ultimately, the network virtualization is what houses the intelligence in the network. We can leverage the existing virtualized network. We can leverage the existing compute resources, and we can start to have intelligent networks instead of stupid networks. A layer 2, 3 command line controlled network is a stupid network. But a layer 7 virtual network is a smart network. And so we can take advantage of the fact that we can have isolation, segmentation, and advanced services like virtual segmentation gateways in a virtual network, and we can enforce zero trust. So you can have a Palo Alto Networks physical segmentation gateway for your main segmentation gateway for your physical network, and there will always be physical workloads, right? The Unix and mainframes are not going away, but now I can add or insert a VSG, virtual segmentation gateway, into the virtual network, and I can spin up zero trust networks much more easily and quickly than we ever could before. See, network virtualization is, at its core, zero trust. That's just how it works. It decouples itself from the hardware, and it's not part of the physical network, so it makes it much harder to attack it. One of the great secrets of all attackers is ARP. ARP. Love ARP. All that layer 2 stuff makes it so easy to attack a network. The stuff that is supposed to just make it easy to move stuff around a network, make it really easy to attack it. And one of the great attack mechanisms is layer 2. That's where we, if we're an attacker, we like to work. Then we have completely isolated networks. Not flat networks, isolated networks. Isolation is so important. You can't have a network that's connected to something without a control in place and expect any kind of security, because it will be breached. Years ago, I was tasked with testing the security of a voice-over IP network for a casino. We went into this casino, we rented a hotel room, we plugged into the back of the IP phone, and through that IP phone jack, we were able to use just a couple of techniques, mostly leveraging ARP and 802.1q tagging, or what's normally called a VLAN, to get from the phone into the financial database of the casino. Because none of the networks were isolated. Isolation is so important. And then one of the tenets is access control is done on a need-to-know basis. This is true not just for users, but for networks. Networks don't have to be all intermingled together. They can be separated. You shouldn't move a packet from network A to network B unless there is a reason to do it. And as you're doing it, you better be inspecting it and logging it and controlling access and inspecting that access and doing all the things that you would do in zero trust. And then the third thing that's happening is agile programmability powered by centralized management. I've always said that management is the new backplane. I hated command line. When I was a CCNA, thinking about becoming a CCIE, should I go and spend years and years and thousands of dollars studying in order to get that lovely little leather jacket? I talked to other CCIEs and asked them about certain things, and they didn't really understand what they were doing. They just knew that they had a whole repository of config files on their laptop, and if they chose the right one and changed the right IP addresses, everything would work. That's a stupid network. And that is a very difficult to manage network, and that is a network that can't be responsive to the threats. You see, we have very static networks because we're afraid of our networks going down, aren't we? We have things like change control. How many people have a change control process in their organization, in their company? Everybody does, right? You have a change control process. And boy, that's so important because you don't want anything bad to happen. But what happens if something bad happens? The change control process kicks in and keeps you from doing something good. It's the irony of it. And there's an important thing to remember, and that important thing is that hackers don't have change control. There's no Hackers Central where you call up and you go, hey, I just tried to attack this network and it didn't work. I'd like to know when is the next hacking window. Oh, 2 a.m. 2 weeks from Sunday. You got it. Okay, thank you. Click. Doesn't work that way, right? But when there's an attack, the first thing that happens is we have to validate it. Is that really an attack or not an attack? We wouldn't want to block good traffic, which usually means email going to the CEO. Or we're doing something like Target did. We're in lockdown because of the holidays, because of Christmas holidays. Don't touch everything. Everything's working. You know, it would have been cheaper for Target to just unplug the whole company during the time that that breach was happening than it will be for them to remediate it. Penny wise, pound foolish, as the saying goes. It happens in security all the time. So how do we solve that? Well, we get more intelligent networks, and we get that by making them more programmable, making them more agile, and making them more centrally managed. We talk about this, about service orchestration, Forrester, but there's a real key component here. The component is, I need something that can intelligently and automatically do something that I choose to do it, and I can consume that in a user interface that is easy and understandable. That looks like an iPad. Is that an iPad? Just quick question for you. Your name is? Gomez. Hey, Gomez. I'm John. Nice to meet you. How you doing? So just quick question about your iPad here. how much iPad training did you have before you were allowed to use that? Zero? You did not go through any iPad training classes? What about, are you a certified iPad user, CAU? No, you're not certified to use your iPad? What is going on with this world? There is a lot of compute power in there, and people are just letting you use it willy-nilly without any controls? That doesn't happen in the enterprise, does it? We have to have all kinds of training and certification. But in reality, what people want is something that's as easy to use as an iPad, that looks as cool as Minority Report, where you have all those windows flying around, and that does things automatically that are supposed to be done, because computers are really good at doing that kind of stuff. 40% of network downtime is caused by human error and misconfiguration. People cause the problems because it's too complex. But we don't want to use computers because they might make a mistake. Well, computers don't make mistakes. They execute programs. They execute instructions. The other thing about computers I found, though, is you can't forgive computers. If Gomez makes a mistake because he didn't have the appropriate iPad certifications, we can forgive him because Gomez is just human. He's just human. You know, he's just human. But if something happens and we can blame a computer, pull that computer system out. It made a mistake. This is the problem we have. We have to change our culture and think about these systems in a different way, right? The rise of APIs, the rise of programmability will make this much more agile so that a computer can say, hey, something bad is going on, and you can go, yes, that is bad, and it goes, okay, I stopped that bad thing from happening anymore. And the rise of APIs is especially exciting because it means we don't have to have standardization anymore. You know, standards bodies are an inhibitor of innovation. Chris has the great line that he talked about, abstraction leads to innovation. But standardization is like pulling the emergency brake. I talked to one guy who's on a bunch of standards committees. He said if we were on the horse standardization committee, sent in to design the horse, we would come out with a three-humped camel. You just cannot do anything well in a standard, but with an API, you can have the agility that you need to interface with anything and have the kind of programmability and the kind of agility to respond to modern threat actors. That's what we have to do. So we'll start with the virtual network infrastructure. We'll have the management layer, the service orchestration, and on top of that will be the user experience. We have to design a great user experience. That was the first thing we were talking about today, is you don't design a product based upon the technology. You want to design it based upon the user experience. And if we don't do that in networking, we will lose the game because our adversary, the hacker, is just as well educated and powerful as we are. People want to adopt and expand the use of software-defined networks, but more importantly, they want programmable network infrastructure. Our data shows this over and over again. The network has to become easier to use, and as soon as it becomes easier to use, it leads you down the road of zero trust, and by making it easier to use, you ultimately make it more secure. So let me just summarize. Zero trust is designed to bring all the various stakeholders together. You've got the executives out there. I do a lot of work with executives now. That is something new within the past couple of years. They want to know what's the potential impact of a data breach to our organization, right? The CEO, the members of the board of directors, a lot of those are interested in zero trust. And in fact, if your company is having trouble, if you've got somebody who doesn't want you to talk about zero trust, let me talk to your CEO. I'll get him or her on board with zero trust in about 10 minutes because it's strategic. Then we have the business. You have people like marketing people, business intelligence people who say, we need to use the data. In fact, I often think that we have two adversaries in security. We have the hackers and we have the marketers, because they want to just use data without respect to how toxic it is. And so they get us in trouble. In fact, the Target breach was probably exacerbated by a loyalty database used by marketing that wasn't properly protected. And then finally, those of us in IT and security, we're sitting here going, we're here to protect your data? What? We thought we were protecting devices and networks. What's this data stuff? We don't even know where the data is because all we care about is spanning tree. If all you care about is spanning tree, you will never know where the data is. Folks, start caring about the data, and now you will start providing value to your organization. So we live at the intersection in the inherent conflict between using data and protecting data. That's where we all exist. That is both our challenge and our opportunity. If we do it right, we can become very, very important to the business, and they will look at us as an enabler of the business, not an inhibitor of the business. That's what Zero Trust gives us. So in summary, Zero Trust, a new mantra: verify and never trust. No trust flag in TCP. You don't need trust. Second, starts at the segmentation gateway. Understand that you've got to have something that controls the access and provides inspection. And then the enabling tech, the thing that's going to set this whole thing on fire, is network virtualization. I've talked to a number of companies who adopted network virtualization in order to make Zero Trust easier, and then it made other things easier as well. This can be the win-win we've been looking for a long, long time in networking and security. And then the abstraction and programmability of all of these things will make Zero Trust ubiquitous. His boss over at VMware told me, Carl Eichenbach, boy, you'd think I could remember that name. Eichenbach says, we're going to make Zero Trust everywhere. Because it just makes sense in this particular threat environment. So untrusted and untrusted, very simple. There's nothing complex about this. And now we have the three technologies to make it happen: a segmentation gateway, network virtualization, and programmability. Those three things together, combined with what you already have, make it so that you can deploy a Zero Trust network very quickly and very effectively.